Welcome to Jacked Engineering. Today we'll be going over merge sort. So I had just spent 45 minutes creating a video where I went through every single part of merge sort and gave code examples, and I realized that the best information wasn't until the very end where I gave an example and just walked through every single line of the sorting algorithm. So we're going to get into some code here pretty quickly. But first, if you don't know what merge sort is, it's a sorting algorithm with O(n) times log n of complexity. If that doesn't mean anything to you, don't worry about it. If it does, that's what the complexity is. So before we do write just some super basic code, here is a brief overview of merge sort. You have an array, let's say of size 4, and you need to sort these into an order. Okay? You break the array in half. You now have a subarray on the left. You have a subarray on the right. You break these in half, and you have a subarray of length 1 on the left, a subarray of length 1 on the right, a subarray of length 1 on the right, and another subarray. Great, now that the array is of length 1, you can recombine them. In this, you do a sort to make sure that they're in the correct order. We'll talk about what that algorithm is in a second. And you will get 1, 3. Then you will combine these back together. You will get 2, 4. And then these two will combine back together to get 1, 2, 3, 4. So a couple key things. This sorting portion that happens in the merge step, right? And then this actual splitting portion, and how do we recursively use merge sort in order to reorganize an entire array, right? So what we're going to do is we're going to start with this merge step, okay? This is going to tell us how the arrays actually get sorted. So we know that at some point there's going to be a left and a right array. So for this case, let's just say that the left array contains 1, 3, and the right array contains 2, 4, right? And we'll just go along with code as we go along with Adobe Illustrate. So let's go ahead and set up our Python file. We'll use good coding practices and create our main statement. So we don't have any method to call yet, but we will, however, define the merge portion of this step. Merge, we know that there's going to be a left array, and we know that there's going to be a right array. And we know that there needs to be an array that is returned, right? So we'll create an array, and we will return that same array. Okay? So how do we actually sort these two things? Well, we're going to use a two-pointer method where we'll have a pointer. We'll call this pointer I, and we'll have a pointer here. We'll call this pointer J, right? And then we have our A array, okay? So what's going to happen is I is going to be compared to J, or the numbers at those index positions will be compared. So in this case, 1 is compared to 2. 1 is less than 2. So we add 1 to our array, and we increment I. So now we have the array with 1 inside of it. We now have our I pointer pointing to the number 3, and J is still pointing to 2, right? So A is equal to 1, and we're going to add another number here, right? So 3 is not less than 2. And so because it's not less than 2, we are going to add 2 to our array. And we are going to increment the J pointer. So now we have 2 arrays. The pointer is still pointing to 3. We have here 2 and 4. And the pointer is now pointing to 4. We now need to add another number to our merged array. This is going to be question mark. Okay, 3 is less than 4. So we can replace this question mark with a 3, okay? So now we've reached the end of our left array, right? We've reached the end here. So what does that mean? Well, that means that any elements that are left in the right array can be appended to the end of here. So this can be 4 can just be added, right? And if this said, 5, 6, 7, we could add 4, 5, 6, 7. This goes inversely. If you reach the end of array 2, right, and there are still numbers in array 1, well, then you can append all the numbers in array 1 to the end of the total merged array, right? So we can return A, okay? So let's go ahead and write this out. So our pointers, right, we want to traverse while there are still numbers inside of our array, okay? So these are going to be our I and j indices, right, indicated up here. We're going to use a lowercase j, but I wrote capital by accident, okay? So while I is greater than, while I is less than left r, the length of left r, okay? And j is less than the length of right r. Okay, we want to do something. Let's see if I can zoom out a little here. Let me make sure that my face isn't in the way of this. See if we can make this a little bit easier to read. And then we'll zoom in here. Yeah, okay. So again, while I is less than the length of R, or the left array, and while j is less than the length of the right array, we want to check something. If that left array at I is less than that right array at j, well then we are going to want to go ahead and add that left array at I, and then we're also going to want to increment I, right? That's this step right here where we saw that 1 is less than 2, and then because 1 is less than 2, we're going to have to move that I pointer forward. Oops, I plus equals 1. Great. In the other circumstance, all right, we see the other circumstance is here when 3 is not less than 2. Well, then what's that else statement going to look like? That's going to be a dot append right array at index j plus equals 1. Awesome. So now that we've done that, we can talk about that other portion that I was talking about at the bottom, where if you reach the end, you can just extend the array, adding all the elements from the array that hasn't been fully traversed. Okay? So all we're going to do is we're going to go a dot extend the left array from the current index all the way to the end. And again, if the array has been fully traversed, that means nothing will be added here, right? And then we can also do, what did I miss here? Oh, the colon goes on the inside, right? And then we can do a dot extend the right array from the current index to the end. Great. So that is all for the entire merge step. Great. So now how do we actually use this inside of a merge sort algorithm? So let's go ahead and define our merge sort. Okay, we'll give an array example. So array is equal to 1, 3, 2, 4. That was the example used before. And then we're going to call merge sort on that array. And we're going to want to print that, right? And in Python, you can actually just call print on an entire array, and it will print. Very convenient. Merge sort with an array input. Great. So now we'll go ahead and get rid of this. Okay. So what happened in the beginning when we had that thing of length, or when we had the array of length 4, right? and it was 1, 3, 2, 4. What was the first thing we did? Well, we split that in half. So that's exactly what we're going to do. We are going to define a middle. So middle is equal to the length of the array divided by 2. Now this is something that's very important, and I'll show you guys if we print that middle, well, something interesting is going to happen. So we're actually going to get an error. Why did we get an error? That's why. Wonderful. Okay, you can see that the 2 that's printed, right, that 2 is going to be 4 divided by 2, but you'll notice that it has this 0.0 after the 2. That means that the type is a double. We don't want that, so we have to cast it to an int. Now that it's an integer, you can see that we get just a plain 2. And that's for the reason that if we have something that's of length 5 or any odd number, right? So 1, 2, 3, 4, 5, we need that middle position to still compute as 2, index 2, non-inclusive, and not be, 2.5, which would obviously cause an error. Okay? So that was the first thing we did, right? Well, we have to define what the left array is as well, right? So we're going to have left as the array from 0, right? So this is like saying from 0 to middle, right? And that's the same as just doing that. And then we're going to have this right defined as the array from middle all the way to the end. Awesome. So imagine that this is just a situation of where we had an array of length 2, right? And it was like 3 and 1, right? And we have our merge method accessible. Well, how would we use this? Well, we'd split it, okay? This would turn into an array of length 1 with a value of 3, okay? So an array of length 1 with a value of 3, and this would turn into an array of length 1 with a value of 1. Well, in our merge method that takes in 2 arrays, right, we would be able to go, okay, 3 is not less than 1. This else statement gets triggered, right? 3 is not less than 1. So we add 1 to our A is equal to 1. All of this left array has been traversed, so the rest of the all of the right array has been traversed, so the rest of the left will be appended. So we'll get 3, right? So again, in the situation where we had 2 numbers, well, what would we want to do? Well, we want to return merge of a left array that is sorted, right? And a right array that is also sorted, okay? Because something is only of length 1, well then we know it's sorted because it's only of length 1, okay? So there's only actually two more steps that we have to do. How do we actually get these values to correlate to something, right? Because you can't compare 2 arrays, you can only compare the values, like what we do here when we are comparing the individual values. So we'll keep using this circumstance where the array is of length 2, right? So we split into 2 different singular length arrays, 3, 1, right? And then when we do that, before we get to this merge step, well, how do we know that left and right are sorted? Well, we know that they're sorted if we do this. Left sorted is equal to merge sort that left side. And the same thing with the right on the right side. And that's it. So in the example that we have, we're going to go through a example of length 2 and then one of length 4, right? So this is the entire merge sort algorithm, okay? So when we click run, we get an error. Why do we get an error? Left equals to merge sort left. Did I define left? Left is defined. We'll be back when I figure out what the error is. I totally forgot to add the condition statement if the array is of length 1. Well, then we're going to return, sorry, you're so used to typing in C or C++. Oh my gosh. Then we're going to return the array. And we'll try that. Perfect. So we'll get rid of this print statement. And you can see that our input of 3, 1 gets sorted into 1, 3. Now we're going to go through exactly what happens line by line with this particular example, and then we'll do it on a larger scale. We'll go quick here, right? So we have the array of length. Wow, that is a horrible square. We have an array of length 2 with 3 and 1. This is right here. It gets passed into merge sort. The length of the array is not 1, so we'll continue. The middle is computed as 1. Okay? So from 0 to 1, non-inclusive, we have our left array created. This left array is equal to 3. We have our right array created. This right array is equal to 1. Merge sort is recursively called on this left array. So we're going to call the function merge sort on this 3. And what is this going to do? Well, it's immediately going to return that array. Okay? So this just returns 3. Awesome. So the same thing is going to happen on the right. The function gets called on the array of length 1 with the value 1 inside. This gets returned. The value 1 is put here. So now the left and the right, because we've returned from here, have a value in this parent function call. The parent's not the right term, but the parent function call, right? So now all we're going to do is we're going to return this left input array and this right input array sorted. Okay, we'll go down here. So what happens? A is created as blank, right? Then we have our I and j, I representing pointer to the left array and j representing pointer to the right array. We have not traversed either array fully yet. So what's going to happen? Is the value in I, or at index I, less than the value of the right array at index j? The answer is no, because 3 is not less than 1. So the else statement gets triggered. Okay? So what does that mean? Well, we go ahead and we add to our A the number 1. Okay? And then because all of this right array has been traversed, we exit the while loop, and then we can go ahead and extend the rest of the left. So then we get A is equal to 1, 3. We are in the parent function because when this merge value returns as this array A, well then that exits the topmost call of merge sort. So there we go. Now we have the array 1 to 3. Now let's go ahead and do this with a slightly larger example. We have an array of 1, 3, we'll do it like this. We'll do 2, 1, 3, 4. Okay? So 2, 1, 3, 4 gets passed in. 2, 1, 3, 4 gets passed in. The middle is, actually we'll do one of length 5, just for edge case's sake. 2, 1, 3, 4, 3, 5, 4, because why not? Okay? The middle gets computed. 5 divided by 2 with integer division is going to be 2. That means that our index split is going to be here. Why? Because from 0 to middle is non-inclusive, which means it will include the indices 0 and 1 inside of that left array. Okay? So now we have our first split. We have 2 and 1, and we also have 3, 5, and 4. Awesome. Okay? So what is going to happen now? Well, we are going to get the left sorted merge sort, or we're going to recursively call merge sort on that left array. What does that look like? The function gets called on this left sorted array. The length is not 1, so we're going to split it again. 2 and 1. Awesome. And inside of this, we're going to do the same thing. We're going to call merge sort on this left and on this right array. Now, because these are of length 1, well, this is actually going to finally return 2, and it's going to return 1. Great. Same thing is going to happen over here. So the split is going to be on this 3 because 3 divided by 2 is equal to 1. So that's just going to be the index 0 because it's 0 to 1 non-inclusive. That means we have arrays 3 and 5, 4. 3 is going to return 3. This is that left getting through, this if length R1 getting triggered. And then this other array is going to have the left and the right split. 5 and 4, both of which will return at 5 and 4. Awesome. Perfect. Well, now we'll go ahead and start with this 5 and 4 since this is just what we had walked through. So we are here, right? So what happens now? Well, this 5 and 4 get passed into merge because the left sorted and the right sorted returned with a value from this if condition. So now we go into our merge and 5 and 4 get sorted just like in the previous example. And I'll go slower when we get to a bigger combination, right? So 4 and 5 returns from here. Then we can go over here. 1 and 2 gets returned from here. Great. So now this function call of length 2 now has a return value. So we have this nested call, or again the recursive call, right? Because this is our first call to merge. This is going to be our second. So this second call now has a returned value, okay? So that's going to propagate all the way back up, and we'll pause right here. So this 3, 4, and 5 also get combined in the exact same way, where the right sorted value is going to be this 4, 5, and the left sorted value is going to be this 3. We're gonna pause right here. So we have two arrays that are now sorted as 1, 2, right? And then 3, 4, and 5. So what happens in the merge step here? So because 1 and 2 is the left array, 3 and 4 is the right array, we have A, okay? 1 gets compared to 3. It gets added because it's less than. Then we increment our pointer forward. 2 gets compared to 3. 2 gets added because it's less than 3. We've reached the end of the left array, so the rest of the right array will be appended, 3, 4, 5, and this is the final return of the merge sort. So that's really it. I highly encourage you, if it's still confusing, to just copy this code and walk through each of the steps and try drawing it yourself. Adobe Illustrate is where I like to draw it, but there's a free web application that you can do. Drawing very much helps. So I would highly encourage that. Thank you for watching. If you have any more suggestions for problems or coding concepts to cover or electrical engineering concepts, let me know in the comment section below. Thank you.